Okay. Wait, are there questions before I get started? Look.
I literally had it open, but it's pressing.
What's that?
You closed the poll?
I did not close the poll.
Not really.
It should be
Wait, never
open.
mind.
Yeah.
I
Yeah.
was on the old poll.
Yeah. Okay. All right. So it's Friday. Today we're going to talk environments and scoping rules. Okay. We got a lot to cover. We'll see how far we get. Okay. Binding and scoping. Okay. So blah blah blah. All right. Pretty much when you are working interactively with R, you'll be storing all of your objects in the workspace or the global environment. Okay. When you execute a function, while the function is running, it creates what's called a local environment or an execution environment, okay? And we've already talked about this, but values that are created inside this local environment inside the function only exist while the function's running, and then they don't appear in the global environment. As soon as the function's done, they're gone, okay? And then objects in the local environment, sorry, let me do this. And just so, okay. And then objects in the local environment will take precedence over objects in the global environment, okay? Or we might say that the global object is masked by a local object with the same name, okay? And we'll just kind of formalize all of this stuff. This is kind of the big ideas that you need, all right? Okay. So, let's say you go C123, you combine 1, 2, 3, and you assign it to X, okay? And what the computer is actually doing is that it binds the name X to this vector 1, 2, 3, okay? And kind of at a deeper level, and I don't want to get all into this, but it creates something, it creates this object 1, 2, 3 in memory. And then, and the name X points to that value in memory, okay? I don't know if you took any CS classes, but this is like a big deal and maybe brings back some memories there, okay? But don't worry, okay? We're just gonna cover at this very basic level here, okay? Technically, okay, and again, R does things that are different from the way Python does the things, which is different from how C and all these other languages do things, okay? So what this does, we've created an object, 1, 2, 3, we've bind the name X points to this object 1, 2, 3, okay? When we do this, Y points to the same object 1, 2, 3 in memory, okay? So that's what this does, okay? So X, the name X points to this exact object in memory. This Y also points to the exact same object in memory. Okay? This command here creates a different object that happens to have the values 1, 2, 3 in memory. Okay? And Z points to that. Okay? So they're different things. Okay? Now, when you modify an object, okay, R objects are immutable, so you actually can't modify it. So when you modify something, what R actually does is it creates a copy of it, and it kind of and it rebinds that name to the new thing. Okay, and there's more subtleties. There's like copy on modify, modify in place, and things like that. Okay, and so what ends up happening is objects get will have names no longer associated with them, and so R has something called the garbage collector running, and it throws away these objects in memory that were created that have no names associated with them. Okay, I didn't put any of that in the slides because I don't want you guys to be bothered by it, but there's the textbook that I reference, Advanced R. They actually have the second edition out, and the second edition you can just read on the webpage. Just type in Advanced R Hadley Wickham, and it goes into a lot of details. If you're interested in how R is operating kind of from a computer science perspective and you want to know the inner workings of R, highly recommend it. Okay. Scoping is how we find objects, okay? How we find values associated with a name. And there's different rules here, okay? So what we have is we have the value 1 is associated with the name y, okay? So when you ask for what is y, R is going to tell you it's 1, okay? All right, inside the function g, we associate the value 2 to y, okay? And then this function is a function of x, and the last line says return the value x plus y. Okay, so if I run g of 3, what is this going to return? Your options are 4 or 5. Okay, what is it? 5. Good. Okay. Oh, I guess I didn't put the answer on the screen. Okay. Well, it's 5. All right. So the main scoping rule that R runs off is called lexical scoping. If R can't find the variable inside the scope, it searches the higher scope. Okay. And so we've got y is 1 in the global environment. We have function f is a function of x, and this function returns the value x plus y. All right, so I'm going to run f of 3, and so when we run this function, x takes on the value 3, and so it's supposed to return x plus y, 3 plus y. What is y? Well, it can't find y inside the function, so it goes to the higher scope, it goes to the global environment, and returns 3 plus 1, and you get back 4. Okay? All right, hang on. Let me just, this thing keeps flashing in the background. It's bothering me. Did everyone respond? Does anybody need another moment to respond to this thing? Okay, respond. All right, and then I'm going to close this. Okay, so that's good, right? This is all easy and should make sense. Okay. Oh, we already did this one, right? So here we've defined the function, the value. Sorry, not defined. We associate the name y to the number 2, and so now when we run this 3 plus y, y takes on the value 2, and it's going to return 5. Okay, and I'm going to say this all over again. So variables and stuff that are defined inside the scope or inside the function exist only for the duration of that scope. If variables exist outside the scope with the same name, those two are completely separate things and they don't interact, right? So I mean, we experience this in our own lives, right? So let's say in your family you have someone named John, okay? A relative named John, and then in your at school you have a friend named John, and your brain already knows that anytime you hear the name John when you're with at family, you're talking about your family's John, and when you're at school, you've got school John, right? I think I just saw a funny tweet or a meme or something, and it was just kind of like anyway, something about the cat and the boyfriend having the same name, and they all call to kind of clarify who's who. They call him Human Neil instead of the other Neil or something, and he's annoyed that he's always referred to as Human Neil. But anyway, we've got ways to kind of keep track of things with the same names, right? And so R has a set of rules that says this is how we keep track of things with the same name. Okay. All right, and then I think I said this already, that a function is its own separate environment. It only communicates to the outside world or whatever outside environment is via the arguments coming in and the object that it returns, right? But it has scoping rules for if inside the function it's asking for stuff that isn't defined inside the function, then it follows the scoping rules to find these things. It's good practice to only use things that are defined inside the function, but it's also impossible to avoid this, right? Because inside your function, you might do like x plus y, right? And that plus is a function, okay? And that function is defined in base R so that R knows that when you use the plus thing, it's adding things together. Like we take these things for granted, but plus is an operator. It's a function defined inside of R. So, okay. The only exception is super assignment, and it's this kind of double arrow operator, and it will search the higher scope and the global environment to do this. Okay, it's dangerous. Don't use it. There's one case where it's okay to use, and that's reference class objects. But in your general programming, don't use it. I'm going to talk about super assignment later today, and you might be like, oh, this is what I want to do, and I'm going to use this, okay? Don't, all right? It's there's almost always a better way to do it. Or no, there always is a better way to do it, okay? And whatever you thought super assignment would solve is probably just going to cause problems later on, okay? All right, so here's some rules, or an example where we're going to just kind of test how scoping goes, right? So I define x, y, and z to be 1 in the global environment. I define a function f, okay? F takes no arguments in. And let's just look at the very bottom. The thing that f is going to return the value of g, okay? I don't technically need this return, but just to kind of make it explicitly clear that this is what we're doing, it's going to return the value of g. G is defined inside of f, okay? All right, so inside f, we bind y to the value 2, and we have this name, we create a function g, where we bind z to the value 3. And g is going to return the values x plus y plus z. Okay. So if I run f, what will we get? I want to give everybody a moment to think about this, okay? So think about this. Don't just stare at this and wait for me to tap the next button here, okay? So I want you to think, what is the value of g gonna? What is the value of f going to return? Is it going to return? I guess some of the options you can think about. Is it going to return 1 plus 1 plus 1 being 3? Is it going to return 1 plus 2 plus 3, give back 6? Or is it going to give back an error? Okay, and then the other question is, after I run f, what is x, y, and z going to be in the global environment? Okay, you guys got your answers in mind? All right, let's see how we did. Okay, f returns 6, okay? So when it runs g and it says x and it looks here, where's x? It's not there, there's no x here, so it finds x in the global environment 1. When it asks for y, it looks for it here, that's not inside g, it looks in the higher scope, it finds it in f and takes the value 2. And then when it calls for z, it finds it right here inside of g and it takes the value 3 and we get 6. Okay, what is x, y, and z in the global environment after running f? 1, 1, and 1, okay? So those are unaffected by the naming of x, y, and z inside the functions. All right, let's talk about environments. Environments is the data structure in R that powers kind of the scoping, right? And what an environment does is it binds names to values, okay? And so here you can create something called a new environment, right? So, I mean, by default, you're generally working in the global environment, you create values here. But here you can create a new environment using kind of the inside E, the $, and you give it these things. And you can think of this as kind of the environment itself is a bag of names, okay? That's what's the values are not stored in the environment contains the names, okay? And then the names point or are bound, or we bind them to values that exist in memory, okay? Environments themselves are objects, okay? And it's similar to working with lists, okay? Because you have like these double bracket things and the $sign operator, but it's not a list, okay? So it's what we call the environment, right? So the type of for E is an environment, and you can ask for the values, like what is the value of A or the $sign of C and stuff like that, okay? objects inside environments are not ordered, okay? So, so there's no, you can't say what is the first or second value in an environment, because it's kind of, you just think of this as a bag, and inside there's names in there, okay? There's no first object inside a bag. Okay, but then if you can ask, what are the, what's the structure and what are the LS, is list off kind of the names that exist inside the environment, and this is what we have, right? And so by default, if you just type in LS in your global environment, it will kind of list off everything that exists in the global environment, right? And so right now I don't have anything there, but as soon as I create an object, I assign the value, or I bind the name A to the value 3, now this name exists inside the environment, okay, inside the global environment. So this is what we have here. So for an environment, everything has to have a name, okay, and because there's no index. Okay, so kind of to differentiate environments from lists, again, single square brackets not going to work. Setting an object to null does not remove it, okay. And you have to remove objects by doing RM, okay? So if I do this, D still exists, and it's now takes on the value null, okay? Whereas with lists, you could just kind of kill objects by nulling them out, right? Or null elements in a list by nulling them out. Okay, every environment has a parent, okay? Every environment has a parent, and this is kind of how we can display this. This blue circle represents the parent, okay? And the way the parents work is that if R searches for a value, okay, and it doesn't exist inside here, it searches the parent environment, okay? So A, B, and C are defined inside this thing, but if you ask for D, it's going to say, I can't find D here, and it searches the parent, and it finds D here, okay? So, so every environment in R has an environment with the exception of the empty environment. The empty environment is kind of the, I don't know, the base, the top tier environment, and it has no parent, okay? All right, so as far as environments go, these are your important ones. The global environment, this is your workspace. This is where you're kind of working with everything, okay? There's the base environment. This is the environment of the base package, and its parent is the empty environment, okay? So when we talk about base R, technically, there's a whole bunch of other stuff. As soon as you start up R, it loads up a whole bunch of things, okay? But base contains like your most basic elements, like things like the commands, the function C, which combines things and to make vectors, and your plus operator, so you can add numbers together. Those are all inside of base, okay? And then again, empty environment is the ultimate ancestor of all environments, I guess, okay? And then when you call environment, that just tells you what's your current environment that you're working in, which in general, in interactive mode, is going to be your global environment. There's something we call the search path, okay? The search path lists all the parents of the global environment. So when you start up R, okay, and let me do session, restart R here, okay? And so if I do search, this is what it looks like, okay? And so we're starting off in the global environment, and then we have tools RStudio, package stats, package graphics, package GR devices, utils, datasets, methods, autoloads, and then base, okay? And then above base would be the empty environment, okay? This is a little bit different. When you're interacting with R, it loads up the RStudio things, which contain functions like view, but here, because I knit it, it had to load knitter, right? Okay, and so this is kind of the picture. You've got the empty environment and then the base, and then you have the global environment, and then you have a whole bunch of stuff, and these are all the packages, okay? that get loaded. And this is kind of what your search path looks like. Every time you call a library, so you say library ggplot or library dply or library mosaic or whatever it is, what that does is it inserts a new environment, okay, into the search path. Okay, so if I do library ggplot2, okay, okay, all right, that's fine. Okay, and now I ask for search. We can see package ggplot2 has been inserted right above the global environment. Okay, in between global environment and Tools R Studio. So it goes right there. Okay, and every time you add one, it just goes right above the global environment, gets thrown into your search path. Okay, most of the environments that we're dealing with are created as a consequence of executing a function. Every time you executes a function, it creates its own execution environment. Okay, and then there's a few things that we have to kind of keep track of. Okay, so the enclosing environment is the environment where the function was created. Okay, every function has only one enclosing environment, and then for the other types of environment, you can have 0, 1, or many of these environments. Okay, so you have the enclosing environment. Okay, you have the binding environment. Okay, the binding environment, okay, is the environment where the name is associated with the function. Okay, so binding a function to a name defines a binding environment. So where that name exists is the binding environment. Generally, you create a function in your global environment. The enclosing environment will be the global. The binding environment will be the global. Okay, in most situations, the binding and enclosing environment are the same environment. Okay, if you create a function inside a function, okay, you know, wherever you've created that function, both of them will be the binding and enclosing environment. We run into differences where the binding and enclosing environment are different when you're dealing with stuff like packages. Okay, and we'll talk about packages and namespaces in a moment. When you execute a function, calling a function creates something called an execution environment that stores all of the variables that are created during the execution. Okay, and then every execution environment is associated with a calling environment, which tells you where that function was called. Did you call the function straight from the command line? Then your calling environment is the global environment. Did you ask for the function to be run from inside another function? Okay, then the calling environment is the environment where is inside the other function where you called it. It's a lot of stuff. Okay, it just sounds like I'm saying environment, but these are different things. Come back, read the slide a couple times until you get it. All right. All right. So again, enclosing and binding environments. When a function is created, it gains a reference to the environment where it was made. Okay, and this is the enclosing environment, and this is what we use for lexical scoping. All right. And then when you name the function, the environment where the name exists is the binding environment. In most scenarios, these are the same. Okay. So, so here, I'm creating a function, okay, where we assign the value 1 to y, okay, so y gets bound to the value 1 in the global environment, okay, so that's what this icon represents. Here's the name y, and it's pointing to the number 1, this object with the value 1 somewhere in memory, okay, and then we also create a function f, okay, all right, with the name f, and it points to this function, which takes on the values, which is the function itself, okay? So here, the binding environment is the global environment, and because this thing is defined inside the global environment, the enclosing environment is also the global environment. So if we ask, where's the environment of f? This is the enclosing environment, that's the global environment. Okay, so the parent environment of a package, okay, as far as the search path, varies based on the other packages that have been loaded, okay? And so here is the function SD, okay? When you ask for the standard deviation in R, okay, you can say, what is the standard deviation in R? And if you don't put any parentheses after it, it will actually show you the definition of that thing, okay? And inside the standard deviation of R, it calls a couple functions. One is the square root, another's the variance function, okay? And so what if I create my own variance function, right? Like, let's say I create variance, and this is function, and we're going to return hello, right? So you say like var, and it returns hello. And this is going to be a problem, right? Because now if I try to calculate the variance of like 3, 4, and 5, it says unused arguments, right? This is an issue. But if I ask for what's the standard deviation of 3, 4, and 5, it works, okay? It doesn't cause any problems, even though when I ask for the definition of standard deviation, it's calling the function variance, right? So what's going on, okay? Well, to kind of keep track that and say, so that it knows that this variance is not the variance that I've defined in my global environment to confuse it, it has what it's called the namespace. It's an environment namespace stats, okay? And so this is where the difference between enclosing and binding environments happen. And so to kind of ensure that every package works the same way, packages require an internal environment called the namespace in which the package functions are defined, and every function in a package is associated with the paired environments, the package environment and the namespace environment, okay? Don't worry too much about this, okay? The package environment is the external interface to the package, okay? This is the environment which the R user uses to find a function in the attached package, and its parent is determined by the search path, okay? You can use the double colon operator. Have you guys seen this notation where you can say base double colon mean or mosaic double colon mean, okay? And this allows you, just in case you have multiple, you have functions with the same name in multiple different packages, okay? Like, because on R, there's like thousands of packages out there, right? And so a couple people might have decided to create 2 functions that happen to have the same name, right? So, I think there's like a prime factor function somewhere out there in one of those packages, okay? And then somebody else might have created a prime factor function in a different package, right? How do you keep track of these, right? So to kind of differentiate these, you can use the double colon operator, which is basically from this package, use the mean function, or from this package, use the mean function, okay? And so that allows you to kind of access, because when you call mean, all right, it's going to go up the search path, right? And so if mosaic is in your search path, it's going to find this mean function first, right? All right, and so so both of these things point to the same object, same function, and this is the name standard deviation inside package stats, and then this is the name standard deviation inside the namespace stats. Okay, and so this is how we find these things. All right, let's talk about execution environments. All right, so this is we've already seen a function just like this, but we've got some pictures to go along with it. Okay, so here's the function h. You take in the argument x, and then what we're going to do is we're going to take in the value 1 and bind it to the name y. Okay, the output of the function h gets bound to the value y, right? And inside the function h, we bind the name a to 2, and then we combine x and a. All right. So when we call the function h, okay, so this is the global environment. H, the name h, exists in the global environment. There's nothing else in the global environment at this time. When we call h, it creates an execution environment. When this execution environment is created, because when it's called with the value 1 in the argument x, this execution environment starts off right away with the name x, and it has the value 1. Okay, and then inside this function, inside this execution environment, we do a couple commands. One is to create bind the name a to the value 2. A is bound to the value 2. Okay, and then it's going to return x plus a. So it's going to combine these values 1 and 2, and that execution environment that was right here, it goes away, and now the name y in the global environment is bound to the value 3. Okay, so everything that's inside here gets lost. Okay, is thrown away. All right, and so again, when you call a function, it creates an execution environment. The execution has the enclosing environment and the calling environment, right? So where was this function called from, and where was the function created? Okay. If you create functions with global environment and call the function in the global environment, then these two things are the same. Okay. In some cases, though, you might call a function from inside another function. And if that's the case, I should say the environments could be different. So you could define a function in the global environment. That would be the enclosing environment. But if you call that function that's defined in the global environment from inside another function, then you have the calling environment is inside the other function. Okay. All right. So the normal scoping rules is that R will use the enclosing environment to search for values that it can't find. Okay, so the function's looking for something, it's going to use the enclosing environment. Okay, R also supports something called dynamic scoping, and I'll show an example. Not going to test you on it. Okay, and you can use the function called get to support dynamic scoping. All right, so let's look at this. Global environment, x is bound to the value 0, y is bound to the value 10, and f is defined in the global environment. Inside of f, we bind x to 2, bind y to 100, and we bind h to this function that's created. All right, what is the enclosing environment of h? The enclosing environment of h is inside f. Okay, the environment that's created by f, right? So when you execute f, when you call f, it creates an execution environment, and within that execution environment, we are creating a function, and so that environment inside f is the enclosing environment of h. Okay, all right, and so inside of h, we do bind x to 50, and we return x plus y. Okay, and then inside of f, we call h. Okay, so here the enclosing environment of h is inside of f, and because we're calling h inside of f, f inside of f is also the calling environment. All right, so here's your question. When I call f, what value is it going to return? Okay. When I call f, what value is it going to return? So f, if you just look at f, it does this. And the value that f is going to return is going to be the value of a, that returned by the calling h. Okay, so what does h return? So h is going to return x plus y. So we're kind of working backwards, right? We look at what is it going to return. So h is going to return x plus y. So what is the value of x? Is it 50, 2, or 0? When we call h from inside of f, what is the value of x? 50, right? It's inside this function. It's going to just use this value that's right there, 50. Okay, now it searches for y. What is the value? It can't find y inside of h, so where does it go? It goes to the enclosing environment, which is f, and it finds the value 100. Okay, so it's going to take 50, add 100, and it returns 150. Okay, and then so h returns 150, f returns that value 150, and so we get back 150. Okay, so I've defined. So everything I just said here is written down here. Okay, so it tells you where it's finding all of this stuff. Is that good? Okay, so here, subtle distinction. I define G in the global environment, I define H in the global environment. Okay, so if I call H, what is this going to return? Inside H, we give X the value 3, and we say return X plus Y. So H is defined in the global environment, so H is going to return, what's that? 13, right? It takes the x3, it takes the y10, returns 13. Okay. Now I call G. Inside of G, x is 2, y is 100, and I call H. So remember, R's rules is that it uses lexical scoping, so it's going to do the enclosing environment of H, right? So when we call H here, what it should first do is inside of G, it's going to search for a function H. Okay, and it says, well, I don't see a function H defined inside of G. So it goes to the global environment and it finds this function H defined in the global environment. And then it executes this function of H. It's called from inside of G, but it's executing H, and so when H gets executed, it uses its enclosing environment, and it's going to say, okay, well, X is 3, Y is 10, and it's going to return 13 as well, okay? So when we call H by itself directly from the global environment, we get 13. And when we call G, which calls H, it uses lexical, the scoping, which searches the enclosing environment, and so G also returns 13. Yes, question?
Does it matter in which order you run? You have to define H before defining G.
No.
Like if you switch, which one you define first?
You have to define the function before you execute it, but it doesn't matter. If I've defined H or if I define G first in this order, like if I swap the lines of code around, it doesn't, like if I define H before I define G, it's not going to matter because, so here, I'm calling H here, and if I ran up to this line of code and I didn't define this, right? So if this hasn't been run yet, and then if I try to call G, what would happen? I would get an error, H not found, right? Because H hasn't been defined yet. Okay, so you can only execute a function after you've defined it, but you know what order you define these things in the global environment doesn't matter there. Okay. All right. So is this okay? That when I call G, I get 13. I'm not going to get 103. Is that all right? Even though inside of G, Y takes on the value of 100. Okay. So here is an example of dynamic scoping. It's the same thing, except inside of H, I use this get command, okay? So what get does is it says get Y from the parent frame, in this case, the calling environment, okay? And this is dynamic scoping, okay? So when we call H from the global environment, it's going to take this value, X is 3, and it's going to search for Y in the global environment, and we're going to get 10. Okay. When I call G, inside of G, we call H. Okay. And so when we call H, it's going to take on, X is going to take on the value 3, but then this Y will use the Y inside the calling environment and get the value 100. And so H returns 13, and G returns 103. Okay? All right. I want to talk about superassignment. So the regular assignment operator always creates variables within the current environment, okay? The superassignment operator, which is this thing, never creates an environment variable in the current environment, but always goes to the parent environment, okay? I guess with the exception, well, I think, of doing it in the global environment, okay. If superassignment doesn't find the existing variable in the parent environment, it's going to climb this scoping ladder until it finds the variable it looks for, okay? And sometimes this means it climbs all the way up into the parent environment, or the global environment, and if it doesn't find it in the global environment, then it'll just create it in the global environment, okay? And so super assignment can mess stuff up, okay? It can be tricky. So here's an example, x, y, and z. Inside of f, I super assign y 3 to y, okay? And then we say return y, okay? So, so when I execute f, it returns the value 3, no surprise there. But when we ask for what is the value of x, y, and z in the global environment, y takes on the value of 3 now, okay? It modified 3 in the global environment without really telling us, okay? And so this can be a surprising thing, okay? I'm going to just skip ahead, okay? You can look at all of this stuff here. I superassign 2 and 1, and I've got a bunch of these examples here, okay? Let me just just say this again. You might be like, oh, this is what I want, right? I want to modify stuff in the global environment from inside my function. This is just what I need, okay? Don't go down this path. It's just gonna lead you to heartache, okay? Don't use it unless you're going to do reference class objects. Okay, so let's say you're doing something and you're like, oh, I want to keep track of the moves that I land on in this shoots and ladders game and stuff, right? And this is something that exists in the global environment. So, oh, here's my function, and I'm going to just keep adding moves to this thing, right? So here's just a silly thing. We're going to just add we're going to have foo defined in the global environment, and we're going to just append values to this thing, okay? And you say, oh, super assignment, this is just what I need, okay? And then you try this out and you go, foo is 2, all right? And then we want to add the square of 5 to this object foo, okay? And so we say, okay, we're going to do this. And then, and we do this, it runs. And then we say, okay, well, let's just check on the value of foo. And it's 2 and 25. And we go, oh yeah, that's great. That seems just like what I needed, okay? So you might be tempted and say, super assignment does just what I need, okay? But I tell you it doesn't, all right? You got to just trust me on this. Please don't use super assignment in your shoots and ladders game. All right, so here, let's try this, okay? So super assignment takes the argument thing and it's going to modify this, right? So here I'm defining bar is 10, and I'm going to do add square, take bar and 6, okay? So, so when we finish this, what is the value of bar going to be in the global environment? And what is the value of foo going to be? So, right, so I have bar is 10, and we're going to run this function, add square, bar 6, right? So what do we think bar should be? Okay, so here's the function as it's defined. Okay, so it's going to take bar and superassign it. So what is it going to do? Okay, well, bar in the global environment is 10, and what happened to foo in the global environment? Foo is 10 and 36. Does that even make sense? So what happened? Okay, so we use this function add square bar. Bar is the value 10 when we call it, right? So we're basically saying add square bar is the value 10, and we do comma 6. And when it does this, right, so this is now takes on the value 10, and we're doing 10, and then this has the value 6, and we do 36. And so we combine them, we have 10 and 36, but then it gets super assigned, not to foo, to foo in the global environment. So this thing, 10 and 36, overwrites, whatever foo was in the global environment. And so these values 2 and 25, those are gone now. They've poof disappeared when we've run this, okay? And unless you're like super careful and diligent about everything, it's easy to lose sight of what actually gets modified when you're calling a function. Because when you're doing this, I don't think anybody expected, or I don't know, maybe you did, expect that foo was going to change to 1036, whereas bar remained the value 10, okay? So if you wanted to do something like this, right? Okay, you wanted to take a current vector that exists and add on a square, that's fine. Take the thing that you want, here I call it baz x, and we're going to return baz plus x squared. And then all you have to do to avoid the super assignment stuff, there's no super assignment here, just say, okay, here's the value foo, which takes on the value 2, and all you have to do, okay, this is the difference, just run the same code, and then just assign the output of that code to the object foo. And then, ta-da, foo works the way we want. Here's bar 10, we run the code, we assign it back to bar, and it gives us, 10 and 25 here, okay? So this is a much better way of doing it. No super assignment involved, no heartache, no confusion, and that's what we've got. Okay, we'll end there. Have a great weekend. We'll see you guys on Wednesday.